In this lesson, we're going to take a look at the concept of common factoring. And what common factoring means is to write some algebraic expression as the product of two factors by dividing out a term or a number that is common to all parts of the expression. Here's a numerical example, just numbers, no variables whatsoever. If we had 6 plus 20 and we didn't want to add the 6 and 20 together, we could common factor a 2 out of this because 2 divides into both 6 and 20. So here's the 2. Now what will go in the brackets after the 2 is what you would get if you divided each of these by 2. So for example, if we divide 6 by 2 and then also 20, 6 divided by 2 is 3. And 20 divided by 2 is 10. So that's why it would be 2 times 3 plus 10. So that's an example of common factoring with just numbers. Now normally we have algebraic expressions like this x squared plus 5x. In order to, and this is the only example I'm going to do with algebra tiles, in order to factor x squared plus 5x, we would want to arrange an x squared and then 5x's, there's 5 x's here, into a rectangle. And it would have to be an x squared and then the 5x's arranged like this. For example, we couldn't put an x squared and then a couple of x's here and maybe 2 or 3 down here. It wouldn't make a full rectangle. We want it to be a full filled in rectangle. Now if we do that and arrange it like this, then this dimension right here, well, this would be an x squared and here's the 5x. This dimension right here would be an x. That would be the dimension, or we could call it the width, I suppose, of the rectangle. And this dimension across the top would be x plus 5. There's 5 ones here, so this would be x plus 5. So the factors of x squared plus 5x then would be x times x plus 5. So that's how it would factor. Now, the reason the common factor is x, because all these terms have x's, and x is actually the lowest common power. So we can factor an x out. And then if we divide x squared by x, that gives us this x. If we divide 5x by the common factor of x, that's why there's a 5 here. Now, just some algebraic examples on this, the bottom part of the page, and also on the next. So we're asked to common factor 8x minus 4. And the first thing you ask yourself is, well, what divides evenly into both 8x and negative 4? And the answer would be 4. Now 2 does, but you always want the largest common factor. So 4 divides into both of those. So 4 is the common factor. To get what's in the brackets, we would divide both of these by 4. And so 8x divided by 4 is 2x, and then negative 4 divided by 4 is negative 1. So that's why it would factor into 4 times 2x minus 1. You can always check any factoring by expanding. 4 times 2x does give you this 8x, and 4 times the negative 1 does give you this negative 4. So you can always check any factoring by expanding. In the second one, we're asked to factor 5x squared plus 7x. So there's no number besides 1 that divides into 5 and 7, so a common factor of 1 doesn't get you anywhere. But they do both have x's. There's an x squared and an x to the first. So x to the first is the lowest common power of that variable that's in all the terms. So the common factor would just be an x. Now if we divide 5x squared by x, you get 5x. And you divide 7x by x, you get 7. So that's why the brackets would be 5x plus 7. Remember, you always check by expanding. So x times 5x is 5x squared. X times the 7 gives you the 7x. In C, we're asked to factor 35h to the fourth minus 25h cubed. Notice that 5 divides into both of these. And also they both have powers of h. H cubed is the lowest common power. So you can factor a 5 h cubed out. So 5h cubed is the common power. So to get what's in the brackets, we divide each of these by 5h. So 35 divided by 5 is 7. H to the fourth divided by h to the third is h to the first. So that's why there's just a 7h here. If you divide negative 25h cubed by 5h cubed, negative 25 divided by 5 is negative 5. And h cubed divided by h cubed would be h to the power of 0, which means no h's. So there's just a minus 5 in the end. In D, 27 and 63 both divide by 9. 3 goes into them as well, but always find the largest common factor. So the common factor has a 9. I'll write this down. Now there's a c squared and a c cubed. So there's powers of c in both of them. C squared is the lowest common power, so the common factor has a c cubed in it. And there's a d cubed and a d to the 6th. So d cubed again is the lowest common power of d in all the terms. So 9c squared d is the common factor. So if we divide this by 9c squared d cubed, that's the common factor, then 27 divided by 9 is 3. The c squareds would divide out completely, and the d cubes would as well. So that's why 27 divided by 9 just gives you a 3 here. And then over here we divide out that common factor again, 9c squared d cubed. So 63 divided by 9 is 7. C cubed divided by c squared is c to the 1st, or c. And d to the 6th divided by d to the 3rd would be d to the 3rd. Remember, you subtract the exponents. 6 minus 3 is 3. So that's why in the brackets would be 3 plus 7cd cubed. The last one here, now we have 3 terms, but it doesn't matter how many terms you have. The common factor divides evenly into all of them. So for 15, negative 25, and 5 divides into all of them. Notice they all have powers of x. So x cubed, x to the 4th, x squared. X squared is the lowest common power of x. So 5x squared would be the common factor so far. And they all have y's. Y squared, y. So y to the 1st is the lowest common power. So the common factor would have a 5x squared y in it, because 5x squared y divides into all the terms. So if we divide this by 5x squared y, 15 divided by 5 is 3. X cubed divided by x squared is x to the 1st. 3 minus 2 is 1. There's a 1 here. And y squared divided by y is also y to the 1st. 2 minus the 1 here would be y to the 1st. Then we divide this common factor into this term. Negative 25 divided by 5 is negative 5. X to the 4th divided by x squared would be x squared, and a y divided by a y means there's no y's left here. The y's divide out. Now notice that the common factor is the same as this last term. It's a really common mistake to think then that there's nothing else on the end here after the negative 5x squared. But remember, you're dividing. This would divide evenly once by 5x squared y. 5, for example, divided by 5 is 1. X squared divided by x squared is 1. Y divided by y is 1. So it's really like having a 1 times a 1 times a 1 in the end, so that's 1. This divides evenly by the common factor 1 time. Okay, a few examples on the second page here too. Now, this may look a little different, but it's still common factoring. We have 5x and then x plus 3 minus 2 times another x plus 3. Notice what's in the brackets are the same. So even though it's a binomial, this is still common factoring. We can factor an x plus 3 out of both parts of this. And so x plus 3 is a common factor. Now remember, you get what the other factor is by dividing out that common factor. So what we're actually doing here is dividing both parts of this by x plus 3. And so this divides out, and this divides out, and what's left is the other factor. So that's where the 5x minus 2 comes from. That's what's left after you divide out the common factor. So the common factor is x plus 3 that we factored out, divided out, and then the other factor is the 5x minus 2. Similar idea in B here. Notice what's in the two brackets is 5a minus 2. So 5a minus 2 is the common factor. If we divide out a 5a minus 2, because we're common factoring that out, then after these divide out and these divide out, 3y plus 7 is the other factor. Remember, you can always check any factoring by expanding. For example, if we multiply this out, that's 15ay. And just to show you that this does work, 3y times minus 2 would be minus 6y. And then this would be a 35a. And then 7 times negative 2 is minus 14. And that should be exactly the same thing you get when you expand the 5a minus 2 by the 3y plus 7. So for example, 5a times 3y would be 15ay. And then 5a times 7 is a 35a. And negative 2 times 3y would be minus 6y. And negative 2 times 7 is minus 14. So 15ay, 15ay, minus 6y, minus 6y, 35a, a 35a, and a negative 14 on the end of each. And so it does expand out to exactly the same thing. So that's just demonstrating that the factoring is correct. Now, example 4 really takes us one step further. We've got to get to this point and then do the common factoring. So this is called factoring by grouping. You would always see an even number of terms. If it's 2 terms, then it's like the examples in the first page. So 4 terms, it could even be 6 or 8 or 10 or 12 terms. But generally in the grade 10 course here, you only see 4. Now, what you do is you look for a common factor in the first 2 terms. And so 15ay and 6y, the common factor divides into, well, 3 goes into 15 and negative 6. But also they have a's, so you can factor a 3y. Did I say a's? I meant y's. You can factor a 3y out of both of these. And actually, I'll write this down, then I'll explain the step. So we can factor a 3y out of the first 2 terms. If you divide 3y into 15ay, 15 divided by 3 is 5. ay divided by y, the y's divide out, so there's still an a here. And then negative 6y divided by 3y, negative 6 divided by 3 is negative 2, and the y's divide out. Now I'm only dividing or factoring the 3y out of the first 2 terms. Then you look at the second 2 or last 2 terms and say, well, what can I factor out of those 2 terms? 35a and negative 14 both divide evenly by 7, so we can factor a 7 of these. So 35a divided by 7 would be 5a, and negative 14 divided by 7 would be negative 2. Notice after those 2 pairs of common factoring, what's in the brackets here are exactly the same thing. So now it's exactly like B up here. So 5, in fact, it's exactly the same question. So we would factor a 5a minus 2 out, and the other factor is 3y plus 7, just like we did in B here. I purposely made this one the same as the one up here. So the idea is you common factor in the first 2 terms and the last 2 terms, and then you common factor one more time. In B, again, first 2 terms, look, 3 divides into 3 and 6 evenly. And notice that now there's an m here and an n here, so they're not the same, but they both have x squareds. So we can factor a 3x squared out of the first 2 terms, and there's a common factor in the second 2 as well. So if we factor a 3x squared out, 3 divided by 3 is 1, x squared divided by x squared is nothing, so that's why there's just an m here. 6n squared divided by 3x squared. 6 divided by 3 is 2, x squared divided by x squared is nothing, so there's just an n here after the 2. In the last 2 terms, now if this is a negative, we always factor a negative common factor out. 5 divides into 10 and 5 evenly, so the common factor is negative 5, and they both have y, so we can factor y out. So negative 5my divided by negative 5y would just be an m. Negative 5 divided by negative 5 is 1, and the y's divide out, so there's just an m. It's a positive m because this negative 5 has been divided by this negative 5, and a negative divided by negative is a positive. Negative 10ny divided by negative 5. Negative 10 divided by negative 5 is 2, and the y's divide out, so there's an n left here. Now notice what's in the 2 sets of brackets is the same thing, so we can common factor an m plus 2n out, and if we do that, what's left is 3x squared minus 5y. So that would be completely factored now. Now I want to point out in this last example is that you can often do this in more than one way. And what I've done here is taken the original question and just switched the middle 2 terms. Negative 5my is now second, and the 6nx squared is third. Otherwise, it's the same question. So if you do that, the factoring will be the same. It's just you're just doing it in a little different fashion. The common factor in the first two terms is just an m. So we can factor an m out of these. M divided in this gives you 3x squared. M divides out, so you still got a negative 5y. In the last two terms, you can divide a 2n or factor a 2n out of both of these. So 6 divided by 2 is 3. The n's divide out, and you've got an x squared. Negative 10 divided by 2 is negative 5. The n's divide out because you factor an n out, and there's still a y here. Notice what's now is the same as the 3x squared minus 5y in both brackets. So that can be factored out, and then what's left for the other factor is m plus 2n. And so we get the same two factors just written in the opposite order, but that's still exactly the same thing. M plus 2n, m plus 2n, 3x squared minus 5y, 3x squared minus 5y. So same thing. So there's often more than one way to do this factoring by grouping. And that's the end of the lesson.